Have you ever wondered what time travel really is? It's a concept that's fascinated us in countless sci-fi books and movies. Imagine being able to hop in a machine, press a button, and suddenly you're in the future or the past. Sounds thrilling, doesn't it? That's the allure of time travel. But what exactly is this captivating concept? Time travel, as we know it from the realms of science fiction, is the ability to move back and forth through time, just as we move in space. A fascinating idea, isn't it? You're here one moment and with a blink, you could be sipping tea with Shakespeare or walking with dinosaurs. In the world of sci-fi, time travel is as common as catching a bus. It's a plot device that has been used in countless novels, movies, and TV shows, from H.G. Wells' The Time Machine to Doctor Who and Back to the Future. It's an idea that has captured our collective imagination like few others. But it's not just a sci-fi trope. It's a concept that has intrigued scientists and philosophers for centuries. The idea of moving through time, much like we move through space, is a tantalizing prospect. It opens up a world of possibilities. Could we change the past or foresee the future? Could we meet our ancestors or descendants? The questions are endless. However, time travel isn't as simple as hopping into a DeLorean and hitting 88 miles per hour. There's a lot of complex science involved. From Einstein's theory of relativity to quantum mechanics and wormholes, the science of time travel is a labyrinth of theories and hypotheses. The concept of time travel can broadly be divided into two categories: traveling into the future and traveling into the past. Both come with their own set of rules, possibilities, and paradoxes, and both are equally fascinating and perplexing. Now let's dive deeper and understand the two main types of time travel: traveling into the future and traveling into the past. So buckle up and let's embark on this journey across the fabric of time. Imagine being on a super-fast spaceship traveling close to the speed of light. What happens to time? Well, according to Einstein's theory of relativity, time has a curious way of behaving. It doesn't tick away at the same rate for everyone, everywhere. Instead, it's influenced by speed and gravity. The faster you move or the closer you are to a massive object, the slower time moves for you compared to someone who's stationary or farther from the massive object. This is known as time dilation. Picture this. You're on a spaceship that can zip around the cosmos nearly at the speed of light, the universal speed limit. You embark on a journey across the stars, spending what feels like a single year aboard your ultra-fast spaceship. Here's where it gets mind-boggling. While you've been gallivanting around the galaxy at breakneck speeds, time has been ticking away at a different pace for the folks back home on Earth. According to the strange yet fascinating laws of physics, your high-speed journey has caused time to slow down for you relative to the people on Earth. So when you eventually return home, something extraordinary has happened. While you've only aged 1 year, 10 years have passed on Earth. Your friends, your family, your favorite TV shows, everything has moved on by a decade. It's as if you've jumped straight into the future, skipping 9 years of Earth time. This isn't just a fanciful sci-fi concept, but a real consequence of the laws of physics as we currently understand them. Time dilation has even been tested and confirmed with ultra-precise atomic clocks on Earth and in space. So, after a year-long journey in space, you might find that 10 years have passed on Earth. You've effectively jumped 9 years into the future. In essence, traveling into the future is not just a facet of science fiction, but a reality woven into the fabric of the universe itself. Traveling back in time, however, is quite a bit trickier and filled with more theoretical issues. In the realm of physics, we encounter something known as closed time-like curves. To visualize this, imagine a path that loops back on itself, like a racetrack. But instead of running laps in space, you're running laps in time. Sounds exciting, doesn't it? However, these are purely theoretical. They're mathematical constructs, not actual pathways we've discovered in the cosmos. Moreover, creating these closed, time-like curves would require conditions or cosmic phenomena that are, to put it mildly, out of the ordinary. We're talking about things like wormholes and cosmic strings, objects and conditions that are either purely speculative or yet to be discovered. So, while the math might allow for a jaunt into the past, the physics as we understand it puts up a few roadblocks. And then there's the paradoxes. Oh, the paradoxes. Let's take the famous grandfather paradox, for instance. Suppose you travel back in time and in a series of unfortunate events, prevent your grandparents from meeting. This means they never have your parent, who in turn never have you. But if you were never born, how could you have traveled back in time to prevent your grandparents from meeting? It's a mind-bending conundrum that illustrates just some of the complexities of past time travel. In essence, traveling into the past is like trying to edit the scenes of a film that's already been made. You're trying to change the outcome of events that have already happened, and in doing so, you could create contradictions and paradoxes that defy our understanding of reality. So, while traveling back in time might make for great storytelling, it's still highly speculative and theoretical. Until we find a cosmic loophole or invent a time machine, we'll just have to enjoy time travel in the realm of science fiction and enjoy the present while it's still, well, present. So we've looked at what time travel is and the two main types, but is it actually possible? Let's start with future travel. Based on our current understanding of physics, it might just be. You see, if we could somehow propel ourselves at near light speeds, time would slow down for us relative to everyone else. This is all thanks to Einstein's theory of relativity. But, and it's a big but, achieving such speeds with the technology we have at hand is, well, a tad out of reach. We're talking about moving at speeds so fast they're nearly equivalent to the speed of light. That's around 676 million miles per hour. So, while theoretically possible, practically we're not quite there yet. Now let's talk about the past. Here's where things get a lot trickier and a lot more theoretical. Some physics theories suggest the existence of something called closed time-like curves. These are pathways looping back in time. But these are just theoretical and would require conditions or cosmic phenomena that we haven't discovered yet. Plus, there's the whole issue of paradoxes. Remember the grandfather paradox? It's a head-scratcher, to say the least. In simpler terms, time travel to the future is a bit like fast-forwarding a movie. You're moving through the plot faster than the rest. But going back in time, well, that's like trying to edit a scene that's already been shot and aired. And we're not even sure if we have the right tools or whether we'd cause a whole mess of continuity errors. So in essence, traveling into the future has some basis in science, while traveling back in time is still mostly the stuff of science fiction. Despite the theoretical challenges, the concept of time travel continues to captivate us. After all, who hasn't fantasized about zipping back or forward in time? But for now, we'll have to leave the time hopping to the pages of our favorite novels and the frames of our beloved films. To simplify, think of time travel to the future like fast-forwarding a video. You speed through time faster than everyone else. You're on a spaceship, zipping across the cosmos at near light speeds while Earth, and everything on it, ages at a normal pace. It's as if you've got a remote control for time, but the fast-forward button is the only one that works. That's because according to Einstein's theory of relativity, time moves slower for you on that spaceship compared to those back on Earth. So, you could spend a year in space and return to find a decade has passed here. In essence, you've leapt 9 years into the future. Now let's hit that hypothetical rewind button. Imagine you could travel back in time, like rewinding a video. But instead of just watching the past, you could interact with it, make changes, and alter the outcome. Sounds exciting, right? But it's also where things get really, really complicated. This rewind function is filled with theoretical issues and paradoxes. The classic example is the grandfather paradox. If you went back in time and somehow prevented your grandparents from meeting, you might erase your own existence. And if you were never born, how could you have traveled back in time in the first place? Now, is this fast forward and rewind of time really possible? Well, traveling into the future has some basis in science, thanks to our understanding of physics and the theory of relativity. But achieving such speeds with current technology is way beyond our reach. As for going back in time, it remains highly speculative and theoretical. The conditions required to make it possible aren't known to exist, and the potential for paradoxes makes it a complex issue. That's a quick look at the concept of time travel. If you've enjoyed this video, please like and subscribe for more content. Until next time, keep wondering and keep exploring.